Yeah, welcome everybody to my VI Week presentation. Can everyone hear me okay? Hopefully that's all good. I'm going to set up, I can't see the chat. Let me share the conversation. Okay, all right. Yeah, so welcome again to my VI Week presentation. Firstly, a big thanks to the LabVIEW community at large for making VI Week happen. It's come together really quick and it's pretty impressive. So it's a real honor to be a part of it. And I don't get the chance to travel to the real NI week very often. So this is a bit of a bonus for me. Kudos to Fabiola and the Delacour team as well for creating DQMH, which we at Wired in Software rely on pretty heavily. So yeah, we're pretty thankful for that. Yeah. So this is coming to you live from Melbourne, Australia, brought to you by the wildlife outside my window here. We've got Bluey the Blue Tongue, Wally the Wallaby, and Eric the Echidna. I made those names up 10 minutes ago. All right, let's get serious. My presentation today is 8 reasons for encapsulating your next device driver in a DQMH module. My name is Chris Farmer. I'm a certified LabVIEW architect. I'm the director of Wired in Software. We're a small LabVIEW development company here based here in Melbourne, Australia. We're an alliance partner with National Instruments, and we're also a DQMH trusted advisor. And I hope today you get some value out of what we're going to talk about. Let me just check to make sure there's no other people wanting to sign in before it gets started. It doesn't look like it. Okay, so I get asked quite often, especially from someone who's interested about DQMH or wants to know more. And when I start to explain, oh, well, what you can do with DQMH, they sort of look at me and in a very specific sense say to me, well, look, I've already got a device driver for my application. Why do I need to put that inside a DQMH module as well? So the simple answer is, yeah, sure, you don't need DQMH to do something like that. If you want to keep something really simple and just need to talk to a device driver, well, no, you don't need a DQMH module. But the way I see it is you've got 2 choices, depending on how far you want to go. Choice 1 is you start your project with a blank canvas, or maybe you have an example already that you can leverage to figure out how to talk to your device. But even that, it's still really not an application level, right, maturity yet. It's just an example. You'll go and grab your device driver, whether that's an instrument you've grabbed off the NI IDNet, or maybe it's the NI DQMH driver, or it could be something completely different. Either way, when you get coding, you pull that driver into your code, and you do the common steps quite often is, setting up your device, acquire some data, plot it on a chart, log to file. Job done. Why do I need to do anything else? Why do I need a DQMH module as well? Well, if that's all you have to do, then great, just leave it there. But speaking from experience, apologies for my home phone ringing in the background here. Speaking from experience, this is a pretty rare thing for what I have to do. My customers have a far more complex problem to solve than that. My customer also has a lot of expectations in the software we deliver. These expectations include things like the software needs to be easy to use, it needs to look good, it needs to be repeatable, it needs to be resilient. Under the hood, it needs to manage memory appropriately. It needs to be testable, maintainable, extendable, all these things. So the second choice is, instead of just starting from scratch, start with the DQMH module, because out of the box, you get all these things covered, right? Delacour, the team at Delacour have already thought about a lot of these things I just mentioned already, right? Repeatability, easy to use, resilience, testable, maintainable, all those things, Delacorp have thought about that already and built that into DQMH. So you're kind of standing on the shoulders of giants when you start with a DQMH module. And quite often as well, your application, the applications we have to write, you've got 3, 4, maybe 5 or even more devices, and sometimes multiple instances of those devices within an application all running together. So managing that from a single VI becomes pretty complex pretty quickly. Using DQMH helps a lot with that. So a show of hands before I progress. Does anyone, has anyone never used DQMH or not even know what DQMH is? If you could comment in the chat, if there's anyone out there that's not really familiar with it. Anybody? We've got a couple of people that used it. Well, look, all right. So we've got some people that have read about it but not used it. So what I'm going to do now, I'm going to do a real quick rundown of what DQMH is. I'll try and keep this short, and I'll try and do my best here, Fab. You know, as I said yesterday, if I don't get this right, my DQMH Trusted Advisor membership's on the line. So, all right, let's quickly do a rundown of what is DQMH. DQMH stands for Delacorp Queued Message Handler. It's a LabVIEW tool, and it's 100% free to use. Just admit a couple more people into the thing. Welcome newcomers. Where do you get it? You don't get it out of the box with LabVIEW, but you can easily download it using the VI package manager, which does come with LabVIEW. What is it though? DQMH is a framework for LabVIEW. It's been created by Fabiola and her team at Delacorp. And by framework, what I mean is that it's a foundation on which LabVIEW developers can use to get a leg up in building an application that takes advantage of a lot of good programming practices. So a lot of the things that we just spoke about before, like easy to use, resilient, testable, maintainable, a lot of those things, it's already been thought about and it's been built in to our framework, the DQMH framework. It comes in the form of some scripting tools, and these scripting tools help you auto-create your application building blocks. So we're talking about modules, we're talking about creating modules, we're talking about creating events, which is what we use to communicate between the modules. We're talking about an API tester. And welcome guys. And also some other supporting tools like the validation tool. So, but it's probably best if I just pull up something and actually show you. So let's do a little demo here. So the first thing, as soon as you've installed DQMH from the VI package manager, it will get added to your tools menu. If we jump over to tools, Delacorp, DQMH, you've got a number of tools that you can call. And the first and main feature of the tool is adding a new DQMH module. So let's just fire that up. That brings up a dialog where you can create a module name. You can select the path of where you're going to create that module. You can determine the type. So by default, you've got singleton, which is basically, as it's described there, a singleton module only ever exists as a single instance. Or you could create a clonable module, which means you can have multiple re-entrant instances running simultaneously. Edit the module icon and hit OK. I'm not going to do that because it's pretty slow on my machine, so I'm going to just hit cancel now and show you one I created earlier. So once you've hit OK, after a minute, it auto creates your module. Okay, so this is a DQMH module, what we've just created here. What does it look like under the hood in the project? It comes as a LabVIEW library, and under that library we have a number of virtual folders we have the top level VI of our library, which is the main.vi. We'll have a look at that in a minute. You also, beside that, get a tester. The tester is not part of the library. So that is what you also get out of the box. Now, you can see the library by default has a number of folders here with a lot of functions. Don't be too daunted by all of that. When you're first getting started with DQMH, you know, that can be a little bit daunting. There's a lot of VIs there. What the heck is this thing doing? Okay, there's a lot of supporting code that goes into making DQMH very effective. My advice is when you're getting started, just trust it for now. Run with it. Believe in the design. It's well tested. It's well supported. Jump in there and have a go. You can slowly learn what's happening under the hood as you go. I want to highlight the public API is here at the top. You might notice there is no access scope restricting it. For instance, the other virtual folders here have private scope. The public API is open or public, and that's what our other application or our application code is going to be calling the functions out of the public API. So that is creating a DQMH module. All right, let me quickly show you. Out of the box, we have main.vi. And if I bring up the block diagram, what we see here is a fairly common design pattern and a proven design pattern in LabVIEW. It's the queued message handler, otherwise known as a producer-consumer type pattern. You have two loops, an event handling loop. The event handling loop handles user events. We have a message handling loop, which processes those events. The user events we're talking about. The user events are what live in our public API. We'll talk about events next. Anyway, one of the things to highlight here is out of the box, this is runnable. I can go and run this module now. It doesn't do anything yet, but anything that I want, but it can run. So you've already got a structure there that works. And this is really powerful. I want to show you as well, I opened up the tester here. This is what the tester looks like out of the box. Right, the tester is simply a VI that sits beside the module that allows you to run the module and, as the name suggests, test our module. All right, so out of the box, we have a number of default requests already laid out here that we can use. So if I go ahead and run, I can run my new module instance and show its front panel. So that is a module running right now. All right. I can have a look at the block diagram as well and see what's happening while it runs. So the tester is a handy little tool that sits beside our module, and it's quite integral in our development. Anyway, that is what a DQMH module looks like out of the box. The next thing I want to talk about is DQMH events. Events are what make our modules specific to an application. They're created via the tools as well. Events are basically a way for us to call our module to action. Either we want to request it to do something, or maybe the module itself wants to broadcast some information to its callers. So that's all done through user events. So if I bring my code back up again, how do we create an event? Simply go to Tools, Delacore, DQMH event, create new DQMH event. It brings up another dialog. Oh, okay, it's running. Sorry, I can't do that yet. Let me close this down. Try again. Delacore DQMH event, create new DQMH event. You get another dialog. This is where we can create our event. This is where we start actually customizing our code to make it do something. You specify your module that you're going to add this event to. You specify a event type. You've got 4 different types there. and you get another window where you can actually put the arguments for your event in. Specify the name and description and hit OK. It goes off and it automatically creates an event. I'm not going to show that, but basically what it will do is in the code, it will automatically update your main.vi to include another event case to handle your new event that's just been created. It will also add a new use case to your message handling loop to handle that new event. And it will also add to the tester a new button. We'll place a new button on here to allow us to call and test that new event. So out of the box, this all happens automatically. You then have to go and actually implement the specifics of what you want that event to do. But this stuff is what you get out of the box. Okay, so I've shown you the API tester. Okay, so how do you get it? Just jump onto VI Package Manager, search for Delacore, and grab the Delacore queued message handler tool, and it'll by default grab you all the associated dependencies. How do you learn DQMH? I suggest you start here. The Delacore website has all the documentation for DQMH. There is a how to learn DQMH, and that's a good starting point for getting further into it. There's plenty of resources on the web, on YouTube and things like that. All right, so that is DQMH in a nutshell. I hope I've done it justice. Obviously, I tried to keep it short as I could, but there's plenty more resources out there to learn more. Now, let's get on to our topic. So to help me demonstrate what we're going to talk about today, I'm actually going to use a real-life module I've created for a customer. So I've got a device. It's a PHEC, which stands for electric conductivity temperature meter. It's a serial interface device, and I've had to create a DQMH module for this device. Now, this device comes in a number of different flavors. You can use one to just read a single pH and temperature reading, or you might have one that does 2 pH readings, or you might have one that's got a single pH and a single EC reading. Well, all of them do temperature, but different flavors. Also, my customer, depending on the machine that he's building, he might need multiple of these instruments at the same time. So, yeah, look, that's the example code I'm going to work with today. So I've actually got a project that I've created to help demonstrate this. I'm just going to talk a little bit more about that now before I jump into the reasons. So we have a DQMH module called meters.lvlib, right? Looks similar to what I just showed you out of the box, but this is actually a real developed and deployed module. I've got a tester, just like we showed you before, but there's some supporting stuff going on here. And just to give you a snapshot of that, up here in my common code, I have a serial port class because it's a serial device, and a serial port simulator class associated with that. And also under my meters folder here, I've got a number of different classes for the meter. And this is the code to help me create an hierarchy of handling all the different types of that specific TPS meter. And we'll talk about that further along. But I just wanted to show you that's what we're going to be dealing with today. So, right, finally, we're up to the reasons. Thanks for sticking with me there. Let's get into the 8 reasons. So reason 1, a DQMH module, pardon me, is an application in its own right. So as soon as you've created a DQMH module in a project, you've effectively created an application. Straight out of the box, you would have seen before with our default module that we created earlier, it already can run. In fact, I ran it, right? So straight away, you've got runnable code. So if you just go ahead and create a build spec at that moment where you make the tester your top level VI, you have an application. And I think that's a really powerful concept. So you're not, that's like I said before, with using DQMH, you're not starting from scratch here. You've got a leg to stand on, and you're already, working with an application level. But let's look specifically now at my VI, my meters example. Let me just close a few of these VIs down. I'll get rid of the default one for now. So, yeah, it's an application in its own right. So, like I said, you can make the tester the top level VI of your application. I'm going to fire up my tester now for my meters module. Okay, so full disclosure, this is not what all of my testers look like. I have neatened this one up a bit. Oh, sorry, I'm getting phone calls. So let me just turn that off. All right, so this is my API tester. It's got a little bit more on it than what we saw before with the demo, with the out of the box one. Let me just quickly take you through what we've got here. The top left section here, right? This is sort of similar to what you get out of the box with a DQMH tester. We have all of the default events that you get out of the box. Below that, we have another section. What I've got here are all the specific requests I've created for my meters module. So I've gone ahead and used the tools, Delacorp, DQMH event, create new DQMH event multiple times here for each one of these buttons, right? And I've gone ahead and implemented all that code. So remember, this is the tester. So as I go ahead and create the events, it adds a new button to the tester. Over on the right, we've got a 3-page tab control. The first tab page has a text box which reports the status. That's the same as what you get out of the box with your DQMH tester. But I've added a couple of extra tabs here just to help demonstrate this is an application. I've created a couple of plots that's going to plot live data coming from my meters. And I've also got a sub panel. And this is just to demonstrate one of the features we build into our device drivers. We want to often insert the front panel of our DQMH module into our overall application, into a sub panel. And so that's there in my tester as well to demonstrate that and to prove that that's working. Let's just run it. So I can run this now, and I can run a new module instance. Simply click on that one. All right, you can see an active module's been created. We get a message over here on the status updated saying it's initialized. I can now show the front panel. All right, that's what the front panel looks like. Now the module's running, but it's dormant right now. It's not doing anything because one of the things we do at Wide-In is until you've sent an initialized settings request down to the module, it's not going to do much. So what we do is we tell the module, hey, you're going to be a specific meter. Now you can see we've got a choice of a number of different meters here. I'm going to pick a simulator today because I don't have the device right beside me. And I'm going to click the initialize settings and show the front panel again. All right, we're now connected. We're now getting readings. These are simulated readings. And my module's running. It's up and going. So yeah, this is how we can test our application. But this tester, which comes out of the box, can double as your top level function. I'm just going to insert the front panel into a sub panel to demonstrate that. So right now the front panel of that module has been inserted there into my tester. So I don't have to have that separate. So we got that running. I can show you on my live plots that we've been starting to receive data. Right, this data is coming from a broadcast event that I've coded up in my module that just every 2 seconds, take a reading and share that data. That's all that's happening here. My tester is picking up on that event, right? Let me show you the code for that. So this is the tester code. It's pretty simple. This is what it looks like pretty much out of the box. Just an event handler, a single while loop. And I am reading the meters broadcast event, meter readings update. We're getting data, we're updating our indicators and adding it to a plot. So that's what's happening right here. All right. So I think that explains that. So that's the first reason. It's an application in its own right, which as I said, I think is a very powerful thing. Is there any questions at this point? All right, I'll keep going. Reason 2, DQMH is a great fit for creating a hardware abstraction layer. So a hardware abstraction layer allows us to remove the device details from our application, resulting in a cleaner application. Like for an example, if you have a DMM and you've got your application, you've got your DMM code, all the application really cares about at the end of the day is just give me the voltage. I want to read the voltage. I don't care where it comes from, right? So it could be a National Instruments DMM, it could be a Fluke, it could be an Agilent, it doesn't matter, right? So the idea of a hardware abstraction layer is that you abstract away from the application the device details and you just provide it with the interface that matters. In this case, reader voltage. Now, Chris Roebuck created a pretty good tutorial on how to do this, which we've followed to the letter in a recent project, and in fact, similar to this application. So how do we implement a hardware abstraction layer in, sorry, I'm just admitting someone in. How do we create a hardware abstraction layer in a DQMH module? So I showed you the class hierarchy before, or the classes. If I go ahead and just click on this one and show the class hierarchy. All right, we get this. That's our class hierarchy. We have a meter class at the top, right? That's our parent class. Below that, I have a TPS meter class. Below that, again, I have the different flavors of the TPS meters that we're using. And then inheriting from those child classes, inheriting from those classes, we have simulator classes. Now, one day we might need to add a completely different brand of meter. We can do so by creating a new child of the meter class and doing something similar to what you see here with the TPS meter class. All right, so that's sort of already got the hardware abstraction. So what is the advantage of DQMH in this particular scenario? So for me, the main reason, the beautiful thing about the DQMH module is that, as you may remember from what I said earlier, our calling application interfaces to our module through the public API. And so these are all the VIs our application can run. If I open up one of them, for instance, obtain pH reading, the interface is pretty basic. And so we're keeping it simple for our application to figure out what data we need to get back. And there's no mention of classes or objects or any object-oriented sort of things in the public API. The DQMH module takes all of that under the hood. And I think that's, for me, one of the good reasons for why DQMH is a good, serves a good purpose as a hardware abstraction layer. So I've talked about the classes here. Okay, how does that look in implementation? Let's have a look at the block diagram. I can fire that off from the tester because it's actually still running at the moment. So this is our module code. It looks similar to what we had out of the box, but we've expanded it to be specific to the meter. You have the event handling loop. We have the message handling loop like we saw before. I've got a third loop here called a helper loop. This is quite a common thing you might do with a DQMH module. You might have multiple helper loops, in fact. And all it's doing the helper loop here is pretty simple. It's just every 2 seconds generating a couple of things to add to the queue so that we periodically get the status data and periodically get the measurement data. Anyway, back to the topic at hand, hardware abstraction layer. So you would have seen before from the tester, right, that to kick off my module, I called the initialize settings request, right? I told it he was going to be a simulator. So when we send that request down, it eventually finds its way down into here in the message handling loop. I unbundled the details and I, based on the meters type enum, have a case statement here, and I pick the module that we've called, and I have a reference to the specific class of that device that we want. In this case, it's the WP80D simulator. So we're referencing this one here, right? That class reference gets passed into the internal data cluster that runs around my message handling loop. The internal data cluster comes out of the box with your DQMH module, and you just add to it as you need. But from this point on in time, any other request we get, for instance, obtain a pH reading, we simply pass that object back out and pass that into our meters parent class VI. In this case, it's the request current data. And because we're using dynamic dispatching and the power of LabVIEW object-oriented, at runtime, we're not running that parent class VI. At runtime, we're running the request current data in this simulator class instead. And everything in this module is done the same way. So at runtime, when we call that initialize settings, that's where we specify, hey, you're now running this object. And if we were to add down the track a new device, like I said, there might be a chance that my customer might want to add a totally different brand. That's no problem. We will build up our class hierarchy. And the only real change I've got to make in my code here is add more cases for my meters type and pass the new object class reference through. Everything else in here stays the same. So that's the hardware abstraction layer at work. Like I said, we're maintaining the object only inside this message handling loop. So the application that calls this meters object or this meters module, sorry, doesn't need to worry about classes or anything. So we're abstracting all that away from them. And I think this is a really great, if you've not done object-oriented before, this is a really great application of object-oriented and a great way to learn it and how to get started, because that's exactly how I learned to do it. Yeah, and an improvement, we could use what's called the factory pattern, where instead of doing what I'm doing here, where I've got it built in statically, the different class references, you could also, instead of doing that, open up a class and from a file at runtime and apply it, which is the proper use of the factory pattern. Okay, so that's yeah, look, that's the hardware abstraction layer. And this has come back to be very useful for me. I had a customer, and I did this, or the same customer we're talking about here, for a different module. Later, they said, we've got a different product to use. Can you add that in? All I had to do was create a new class, and away we went. So the beauty of it all, the application, it's none the wiser, right? It doesn't know that there's a new class apart from that initialize settings request at the start. So that's reason 2. How are we going for time? 11:38. The reasons don't take as doesn't take too long. So reason 3. All right, have you got more than one instance of a device? No problem, you can use a clonable. So this clonable feature of DQMH, which I haven't talked about yet, this is one of the main things that attracted me to DQMH, because prior to DQMH, I was doing a lot of work struggling with the fact that when I had a system and I had multiple instances of a device I had to talk to, I was doing that fairly primitively, using functional globals and various methods. There was no real way for me to instantiate. I hadn't tried classes or anything at this point. We're talking about 4 years ago. So when I saw clonable, this really got me interested. So yeah, look, clonables is a great feature of DQMH. Now, the module that we're talking about here today is a clonable, right? Because like I said to you earlier, my customer needed, and his systems have 1 or more meters. So the beauty of a clonable is when you go to DQMH, add new DQMH module, and you can select right there what module type it will be, make it a clonable. It goes and creates all the code. It adds some extra functionality into the folder to take care of the clonable. It also makes a lot of the VIs inside it shared clone reentrant. And the beauty of the clonable is you can call it more than once. You can have them running in parallel. You can run as many clones as you need. So let's demonstrate that. You've already got this one module running that you've seen already from my tester. That's still sitting there plugging away, taking readings. I just go to my tester here and I simply run new module instance. I've now got a second module running. I can select, so you can see now it's updated. The module ID is just the number, the instance number. We show the front panel of that one. So I've got that one running and I've got this one running. And he's dormant because I haven't initialized him. I'm going to make him a WP81 simulator. You can see my module 1 status and module 2 status are both lit up green. When I've sent the initialized settings, he's now connected, he's now running. This one over here is taking 2 pH readings because he's a WP80D. The WP81 gives me a pH reading and an EC reading. If I go to the live plots now, I'm now starting to take readings from my second module. So this is demonstrating the power of a clonable. If you need to, if you only have one clone, you can simply run it as a singleton. And actually, my advice, which is sort of concreted in my mind in the last week while I prepared this presentation, is that when you're making a DQMH module for a device, I highly suggest you start as a clonable by default, because several times now in the last year, I've gone to create a singleton device module only to realize it should be a clonable, and I've got to then go and create a clonable. There's no automated tool to convert. So yeah, start with a clonable if in doubt. And also, when you create your clonable, and this one bit me only weeks ago, all the sub-VIs in your code, for instance, all my classes here, all these VIs, they need to be shared reentrant clone, because especially if you're trying to talk to a serial port, you might have a read function where you've got to wait a second for data to come in. If you've got 5 instances, then it's going to take 5 seconds before it gets around to being able to read again. So that exact problem happened to me on my last project because I forgot to make them shared reentrant clonable. So yeah, don't forget to do that. What am I talking about when I say that? I don't know if I can show the, because it's running, but if I just bring up another VI, no, that's running as well. If I go create a new VI, if I've got a new VI and I go VI properties, execution, you can change the reentrancy. So if you make it shared clone reentrant, that means multiple clones of that sub-VI will happen at runtime. So that's what you need to be doing if you're using clonables. All right, I hope I haven't lost you all. That's my third reason. All right, reason 4. This builds a little bit on what I was talking about before with the hardware abstraction layer. Reason 4 is keep your device management hidden away. Sorry, I'm jumping to that a bit quick. Okay, reason 4. The beauty of a DQMH module is that you can wrap up all the details about talking to your device. And it just means that at the end of the day, your application is going to be a lot cleaner. It's going to be less cluttered with device stuff that's kind of not necessary. And if you're writing an application, you can make it a lot cleaner by hiding all that away inside a DQMH module. What am I talking about here? I'm talking about, for instance, you saw before with my meters module there, right, that under the hood, every couple of seconds I'm generating a request to get some current measurements. By doing that, I'm automatically polling it, and I'm also checking the status. Now, if we suddenly lost a connection because it's a serial port and it's not the most reliable of interfaces, my module can act on that and try and resolve it, and the application would be none the wiser. So you can push all of that responsibility down. Another example is if you get a timeout error or you get a disconnection error. Well, you can go and try and in your module, handle that. So that once again, the application doesn't know. For instance, here is an example. Here's my error case. So any error that gets generated in my module will get picked up in this message handling loop case. And I've got a very specific error code here, 8688. If that happens, it means we've got disconnected, and it just tries to reopen the COM port. So we're handling things under the hood. The device is taking care of a lot of its own stuff. And that means your application is going to be more resilient and it's going to be simpler. It also means you've got a cleaner interface to your application, as we've seen. Like I said before, with the obtained pH reading, we've already hidden away the classes and everything. That's not publicly available. And also, you might have a thing like, I've got a request here, perform calibration. That prompts my module to go and do a number of steps. We're handling all that under the hood, but at the top level, it's just one request. Okay. Reason 5, which is similar. Reason 5 is similar to what I've just been talking about, but I wanted to highlight something specific here, and that is safety. You can build intelligence and safety into your DQMH module. For example, a real life example. Excuse me, my customer, same customer that's using this meters one, he has a motion control system with 3 axes of motion. Now, we need to be able to move our motion system to various locations, but you can't just put in any old location. There are certain points where if you tell it to go somewhere, you might damage the equipment. Now, it's not electrically or mechanically protected, so we've been able to build into our DQMH module a bit of safety. For instance, if we wanted to move to a certain XYZ location, what we do is, first of all, we move in our X and Y planes. And when we get to X and Y, and before we move Z, we can at this point check a couple of digital inputs that are coming in. And these digital inputs are basically reading optosensors to suggest that we're in a valid position for us to be able to move the Z. If those things both give us the green light, we can move our Z safely. If they're not, then we can throw an error and saying we moved to XY, but we weren't allowed to move Z because we weren't in position. You know, this is a really powerful thing that we can build into our DQMH module. The upside, once again, is the application code that sits above all of this is none the wiser. Our application code just says, move to XYZ, tell me when you're done. The DQMH module takes care of that process then and making sure that it's safe to do so. So I think this is a really powerful concept that we're using a lot in our DQMH module or DQMH modules. The responsibility for managing that is resting with the person who's writing up the code for the motion controller. The person who's writing the overall application code can rely on that DQMH module to do its job. When I talk about intelligence, what I'm talking about here is you might build into your code an analysis. So as you're taking readings, you might be able to analyze the performance of your device or your motion controller, for instance, and work out, you can maybe build some machine learning into there and do some self-tuning or reconfigure itself. So I really think this is a good fit for industrial 4.0 kind of applications where we're trying to make things smarter. Yeah, so reason 5, build intelligence and safety into your DQMH module. Okay, hope everyone's following, keeping up. Reason 6, using DQMH, you can prevent your application from being unusable if your device isn't connected. One of my pet peeves with opening primitive LabVIEW applications is, sorry if I sound arrogant here, but when you open it up and if the device is not connected, you're affronted with this awful LabVIEW error, and I just hate it. It's just an awful user experience. So, you know, at best, your application just closes. At worst, you get an error dialog popping up constantly and you hit OK, 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 and you can't get rid of it. Or even worse, it just sits there and crashes. Glad to hear someone else is feeling my pain here. Thanks, Mark. So by putting everything in the management of your device inside a DQMH module, you're kind of by default taking care of this problem, which is really powerful. So let me demonstrate this, right? Let's go back to our tester here. What I'm going to do, I'm going to send down my initialize settings command to one of my meters again, and this time I'm actually going to say you're a real meter type. In this case, I'm going to make it WP81, not a WP81 simulator. I don't have a WP81 sitting here, and to emphasize it even more, I'm going to give it an invalid COM port. I know COM123 does not exist on my system. So if I send that down, all right, I'm sending it to 414.003. All of a sudden, I'm getting some errors being reported from that module, right? Now, the important thing here is that I didn't suddenly get a big error and my application is no longer usable. My application is resilient right now because it's found the error and it's reporting it to me, but we're still running. I'm still getting data coming in from my first one, okay? The second module is still running, but he stopped reporting data. So what's my point here? My point is, you know, my application didn't crash and die a painful death. Instead, it's resilient and it's allowing me to work out why. Okay, I'm not getting data in my plot. I can show my front panel. Okay, what's my error? I'm getting an error code. I'm not getting any data. I can copy this error code and go and, explain that error code. The given session or object reference is invalid. Okay, something's really wrong here. All right, so I've got the tools here to interrogate it more. I think this is a really powerful thing. It results in such a better user experience. You're using DQMH helps you prevent from horrible errors if your device is not connected. Okay, we've got reason 7 now, 2 more to go. All right, this is a really important one for me also using DQMH. By using DQMH modules, you're able to now view what your DQMH module or your device specifically is doing in parallel to running your application, okay? So back before DQMH, before I knew about it, I found this really hard, and I always wanted to be able to do this, especially as I guess as an integrator of my application, trying to debug things. I've written a lot of automated test sequence applications, and when you've got such an application, you're creating, I was just using simple LabVIEW libraries. I mean, they worked well, they were easy to use, but they weren't very smart in what I could do with them. So when I'm initializing all these things and running an automated sequence, I can't really look under the hood and see what's happening whilst I'm actually running. But with a DQMH module, because we've got that DQMH module, it gives us that layer to be able to do this, and we can do this in parallel to running real time. And in fact, we're seeing that happening right now, right? Our tester, I'm using my tester as an application in today's examples. He's running, but at the same time, I can see what's happening inside my module at the same time that my application is going. So let's say my application is doing something a bit more automated, and there's an automated sequence of events that you can't sort of stop, or you don't want to pause and look under the hood. In real time, I can open up the front panel of my DQMH module and see what's happening, right? You've got to obviously put the things you need into your DQMH module to make this happen. But I can see that I'm taking my readings. That's all looking good. I can look at my little activity log file, which is something we add to our devices, and I can see everything's coming in here. That's all looking good. So I've got the power to see all that running while my application is running also. So that's one way of doing it. The other way is, in this example, I'm making the tester my application, but quite often you'll have an actual application and your tester is just your tester. So you can use your tester to do exactly what I'm doing here, to sniff what's happening under the hood. And that's where our status text box here helps. One tip there, though, is if you're going to use this technique, you want to use the status updated broadcast event quite regularly inside your module, because then it will report a lot more information into your text box here. But yeah, look, in parallel, you can run and have a look at your module while you're running your application. All right, we have one more reason. How are we going for time? We're a little bit late. I hope everyone can stick around a little longer. Reason 8, use templates as a common approach for your team. So you can create a template, a DQMH template, based on the device driver approach that you and your team are applying, or any DQMH module, but we're talking about device drivers today, so device drivers. If you go and create a template, then you've got a starting point that everyone can leverage. And it's a great little feature of DQMH because I requested it. Delacorte DQMH module, create a DQMH module template. Fire that up. Tell it what DQMH module you want to start. It uses your starting point for a DQMH module template. Tell it what the description. Tell it where you want it to live. Hit OK. It will go and create a template based on what you've created there. And you can go and find it when you, straight away after you've done that, and you go in and add a new DQMH module, it will appear in your module type list. So you can see I've got a number of ones here, right? That's not what you get default out of the box. You only get a handful out of the box, but we've gone ahead and added our own. So we have a device module template clonable and a device module template singleton. Okay, and these templates that I'm talking about here, they are based on and very similar. Well, sorry, the meters module that I'm demonstrating today, that's based on these device module templates. So basically, the advantage of that is so we can now, as a team at Wired In, whenever we create a new device, we can start from that template and build on the work we've done previously. So what are we talking about when we talk about creating our own template? Well, we've added a bit of functionality on top of the default template. Things like we've got a couple of events that we make common. So we've got the ability to lock our front panels. For instance, if I lock the front panel controls of my module, it goes and locks things. So if I want to prevent someone from interacting with my module while it's part of an automated sequence, I can do that pretty easily through that request and then unlock it when it's available again. The insert front panel into sub panel, that's also a default request. So we've got built in some default requests that live here under the public API. So obviously, a few of these are quite specific, but we've got a couple of default ones. That's out of a box for our template. We also reuse a lot of concepts like the activity log that you can see happening here. All of our device modules have this built in. We might have a common layout, a front panel. You might have a specific color or scheme or font scheme you want to use. You can build that into your template. And yeah, look, some of the things we were talking about before, like device management, error handling, making our code a bit more resilient, we've put that into our template as well. So out of the box, out of our box, we have a template that we can leverage that's very common. This promotes a lot of consistency across projects. There's a lot of familiarity for our developers, and any one of us can jump into a module and quickly learn about what that module's doing because there's a lot of familiarity there. So I really encourage, if you're using DQMH, to consider the templates to share across teams. All right, that's reason 8. So I've got a bonus reason. I thought of this after I'd come up with the 8 and the title. With DQMH, it's really easy to include simulation of your device. Now, as you might have seen, I'm already demonstrating it here, okay? I've added, under my class hierarchy, some simulator classes to handle, these guys, when we request current data, they're just generating random numbers, as you can see. So simulation is fairly easy to build into the DQMH framework by doing something like that. You don't have to strictly use classes, but in this case I did. It's really a really powerful thing. There's some really good features, good benefits that come from this. In this project example, my customer's on the other side of the country, so I can, I don't have all the instrumentation here in my home at the moment, or in my office, but I can simulate all my devices using this technique, and that means, I can test my application, all my application code, and just have my devices being run as a simulator. When we get to the real thing, talking to the real machine, we've ironed out a lot of the bugs because we're able to simulate things. And secondly, my customer loves that he can install this software on his laptop, and whether he's on the road or he's just doing a virtual meeting, he can demonstrate the software from his office. He doesn't have to be standing in front of a machine. He can show that off to a new customer and show them how the software works, and just using simulated devices. So it's become a very powerful sales tool for him. So yeah, simulation really helps. It was really easy to add to DQMH. And once again, my application code up the top, it's none the wiser. It just happily runs. Okay, so yeah, reason 9, bonus reason, it helps with simulation. Okay, that wraps up my 8+1 reasons. Thank you so much for sitting this one out. I hope that it's been of a lot of value to you. I'd like to open it up for questions. I realize we've gone a bit over time. Sorry about that. 1 or 2 people have had to drop off. This meeting is being recorded. Thankfully, I remembered this time. But yeah, I'd like to open it up for any questions in the audience. Or any thoughts? Okay, we've got a question here from Barry. What does the end user's application front panel look like? What does the end user's application? Well, it can look like anything you want, Barry. In this case, right, my application for demonstration purposes is my tester. What I wanted to demonstrate here was that the tester can be an application. It's an example application, but what we end up doing is we'll write another module that sits above the meters module, and that is our application module. Yeah, so it you know, in this particular machine, it's going around, it's using that motion controller I talked about before. It's going around and moving to different soil samples and moving, dipping a probe into the soil sample, taking a reading, displaying it on a screen with a whole lot of circles showing you what's happening. So it's very customer specific, but yeah, you can make it look whatever you want. Your other question, and does the test meters API run in the background or is only used in the development process? So Fab's saying it can be ran as a sniffer. So yeah, you can choose at runtime whether you want that running or not. You don't have to have it running. You can have it hidden away. You could build into your code a debug feature that shows it if you need it. But when you go to deploy the executable, by default, you won't be showing your tester. Yeah, and Fabiola saying in the chat that her presentation this morning, also part of VI Week, shows an example of that. Thanks for the question, Barry. Any other thoughts, any questions? Okay, I've got another question. Any benefit using with test stand? Yes, absolutely. The second reason I spoke to, this is from Mo Win. Thanks, Mo. How are you? The second reason, when I talked about harder abstraction layers, that's a really powerful concept for when you're running with test stand, because your test stand is not having to worry about all the device details and the clutter that revolves around that. You're not having to pass, references in and out of test stand to LabVIEW. And there's some good examples out of the box with DQMH to show you how DQMH works well with test stand. So yeah, yes, it works well with test stand. Just trying to keep up with the chat here. Runtime memory. How much does DQMH app used compared to other consumes? Yeah, Fab probably can answer that one better than anyone. She says you can keep all the references and events within the DQMH modules. You can leave the, we're talking about test stand there still. Fab, do you have any thoughts on Peter's question?
Okay, I think it's going to be easier to go on microphone. Can you hear me?
Yep.
Okay, so well, if you are sending a small package of information via the events are the, and you can benchmark this. Events are going to behave the same as queues. If you start getting a problem where you have memory leaks or things that start to fall behind, then you can look into changing the payload of your events. So instead of sending a 2 GB array, you send a DVR for it, and then you're back to the same performance as a queue. Now, and I tell these to people, you wouldn't pick up DQMH because you have a problem that has to be super performant, and then you say, okay, I'm going to use DQMH. Normally what we do is we use DQMH, and then where we know that the performance is needed, then we go and address that. There's no use on implementing all your time on making everything super performant when only 5% of the application needs the performance.
Can I jump in though? You're talking about really extreme high performance here.
Yeah.
Right? And so 99% of the time, at least in my experience, that's not necessary. We're only talking about the highest of high performance requirements.
Yeah. But and we have used DQMH in those high performance applications. We are currently doing one where it's 2 gigasamples per second, and we're displaying images, and we have multiple modules. One module is doing the acquisition, communicating with the FPGA. The other one is doing the displaying. The other one is doing the analysis. And there we had to get creative to make it more performant. And if you have questions about that, definitely go to the forums, and we can help you with that.
Yep. Thanks, Fab. Kim is just asking to discuss breaking the coding up for the team with modules. So yeah, that's certainly something at Wide in Software. We've found that DQMH is promoting parallel development because for every device we can create a DQMH module. For every application level thing we can create a DQMH module, and so we end up with a whole lot of DQMH modules. One person can be working on, the meters DQMH module. Someone else can be working on the motion controller one, and they're not going to get in the way. So when you get to merging things in your source code control, you're not standing on each other's toes too much. Yeah, there's a little bit at the top level for your top level application that tends to get in the way a little bit, but internally we've got a process to work around that, and it only happens pretty rarely. So it's a really great way to work as a team, DQMH. Just getting some thanks from everyone. Thank you guys for your comments, and I don't think I've missed any questions. Yeah. All right. So great presentation, Chris. Thanks, Kim. Thanks, Renew. And I just wanted to take the opportunity now and let everybody know that we're putting together a DQMH podcast. It's going to be an 8-part series talking about DQMH and all things DQMH. A lot of the episodes are going to be built around an interview with every one of the DQMH trusted advisors, talking about how they use DQMH and how they extend DQMH in their own way. So keep your eye out for that. The first episode should be available next month, so that's going to be exciting. And I've said it now, so I have to go and do it. Yeah, some more comments. Thanks, guys. Thanks, Mark. Thanks, Moe. And yeah. All right, we're just about done. Thanks. Thanks, Ing. That's Patrick. Is that Patrick? All right. Well, Thank you so much, everyone, for joining us today. Yeah, once again, VI Week, awesome initiative. Fantastic to be a part of it. And thanks, Fab, for chipping in with a couple of comments there. And yeah, appreciate everyone joining us today.